Good morning, everyone. My name is Vinod from Wipro Technologies, and I have my colleague Soumya. We'll be jointly giving this presentation on SwordFish. So what we want to talk today is about the manageability trend in the storage or the infrastructure, the compute infrastructure, and what are the new emerging standards and what we have done taking the SNIA SwordFish as a storage management standard. So that's the stuff that we want to talk. So agenda is something like what is the new change in the manageability, right? Why are there new standards coming in? What is the current problem? What is the future trend? That's what we'll talk about. And then we'll get detail into the redfish and swordfish. I'm not sure how many of you are aware of redfish or swordfish. Okay, there are people who are aware of it already. But the adoption is coming, and we are sure in probably going forward in near future, most of the management product will start using these interfaces. So that's why we thought it is important to talk about this. Right? Then we will have a look into swordfish, like how exactly this management model works, what is the technology aspect behind it. Then we will talk about our contribution here, where our intention is, okay, when we looked at this, how can we make the application developers' life easier, right? I mean, why do they have to understand the swordfish, redfish underlying protocol schema? How can we make it easier for them to use it? So that is our thought process, and the JavaScript library where the SRM, or Storage Resource Management UI, can be made faster. And we're also thinking about building a Python library where you can have a software-defined storage system can use the Python library to interact with the redfish server or swordfish server and make the management easy. So that's the concept. So we have a demo of our sample application using this swordfish protocol. How can we interact with the storage system, get the status, set some status. So that's the demo. And then we'll talk about questions. So I talked about this, right? What are the manageability challenges, right? Today, if you look at the entire compute, storage, network, that infrastructure is changing, right? It's rapidly changing along with digital. So that's why I talk about the digital infrastructure, right? Any company who says we are into digital, that means they have to have digital scale in the infrastructure. When you say digital scale, it's web scale, or the buzzword is hyperscale, right? Hyperscale infrastructure. And then there's also another nuances that is hyper-convergence, right? Where we have both compute, storage, network, everything in a single environment, which is making the manageability much more complex, right? So one is the complexity of scale. Second is the complexity of convergence, right? How do you ensure that you have a single management protocol which can cater to all your compute, storage, network needs, right? So if you look at the scale, right? With the scale, all these problems comes, right? I mean, we have been working in several management products which works when you have up to 24 or 48 or 64 nodes. But if the nodes go high, creating an additional volume or creating an additional pool, that takes a lot of time. And from an administrator perspective, you sit and click on your tool, and it takes 5 minutes to come back with a response. It's really problematic, right? And if the scale goes, especially when you want a digital scale infrastructure, which is currently made using commodity hardware, which are connected to give you a scale-out environment, and adding a new storage volume or adding a new pool, if that takes minutes, then it's a problem, right? And that is because of the current management protocols issue. That's what we call about this performance, reliability, and security aspect, right? So with the scale, these are very important. The performance is important, reliability is important, and security is at most important. I mean, especially with the WannaCry ransomware thing, the security of your protocol is important, right? So those are the three aspects when we looked at, and that's where we think the new management protocols are coming, right? And then the last one is modeling, right? Today, gone are the days where we have one single vendor's hardware in your data center, right? There will be combination as a multi-vendor ecosystem, right? You can have a single box working as your compute, storage, network, and a box from a different vendor working together, right? So now you need a multi-vendor environment, and you should be able to model the multi-vendor environment in an easy way, right? And most of the current protocol doesn't allow that, or current management standard doesn't allow that. And then non-standard tools and framework, because you don't want a different protocol and interface to your manageability where your mainline data, right, or in-band data is using a different protocol. Because I usually think if you want to manage the web scale transaction, you need a web-based interface or an interface which uses web protocol. So that is underlying thought behind Redfish, I think, when DMTF thought about it. So basically, solving the web scale manageability problem, that needs a web interface-based protocol. That's as simple as that, right? I mean, you don't want a different protocol and semantics to manage a web scale interface. Second one is we talked about that chattiness, right? I mean, if the management protocol is not slim, right, it is very easy to get this entire communication cause more performance issues, right? That's what we call about less chatty. You want to gather more information using less transactions, right? That is a problem that we see either using a WebM or SMIS architecture. Now, with the modern architecture, what we want is you get two transactions and you should be able to get all the protocol, all this topology identified. So that's about less chatty. So when you have hundreds of nodes, thousands of nodes, the chattiness in the management protocol becomes overhead. So how to avoid that chatty interfaces? That's one of the goals. Second one is common APIs, right? As I talked about, the APIs which the developers are more used to. I mean, why do you need a SIM-based or a different protocol altogether to be learned when you know that, okay, you can manage the entity using a common standard protocol? That's one of the. And the last one is language support, right? You want to use something which is mostly supported by languages, because today if you talk about most of the automation is done Python or Node.js, then why don't we use something which is very frequently or very commonly supported by these languages, right? So those are the underlying thoughts when people started thinking about what all the management problems that we have today and how to address that. So then, when you decide about what is the next generation management protocol, right, what are the choices, right? Choices is number one, it should be using web protocol, right? So HTTP, HTTPS. The beauty is with HTTPS, the security comes in, which is very well known and not mostly broken yet, right? And that is a well-known protocol. So you should be able to have the common CRUD semantics like create, read, update, delete, right? Those semantics managed using, say, HTTP protocol, right? HTTP over, so we will talk about REST. So how can we pass that using that? And then make the discovery easy, right? How do you ensure the topology of the system to be discovered easily, right? And that is one of the goals. And primarily out of band, I mean, there are in-band version of Redfish, SwordFish communication, but the main mechanism to interact with servers out of band. That's one of the stuff, because you don't want to really go and interact or interfere with your actual data traffic. And last one is easily extensible, because the standards are good, right? It's good so that everybody can talk the same language, but the vendor might have to add some extra secret sauce to ensure that his product stands out, right? So it should be extensible. So what is the support for extensibility? And lastly, important is it should support both all your compute, storage, network manageability in the same way, which is a key aspect of your hyperconvergence, right? When the entire world is moving toward hyperconvergence, you really don't want the management guy to tell, oh, for network, you use this particular standard. For storage, you use this. And for your server, you use the IPMI v2. So not like that. You use a simple common standard. So those are the important choices. And when you talk about actual protocol, there were discussion about should it be SOAP or REST, and what is the commonly used web interface protocol, REST, so go with that. So those are the kind of choices made, and that is what has been well decided by the DMTF and SNIA together for this SwordFish and Redfish. So with that background, I'll introduce the SwordFish and Redfish. So Redfish is the basics of Redfish. It's a server management protocol which DMTF coined, like, I think 2.5 years back. So this is basically the REST plus HTTP plus JSON, right? So REST is the communication protocol, the media is HTTP, and JSON is the way that the data is transferred between client and server. So it's very simple, because everybody knows how to handle JSON data, right? There are a lot of language support, be it Python, be it JavaScript, maybe it Node.js. Everybody will have libraries which can parse JSON data, right? And REST is very commonly used in the web servers, which is proven to be scalable, right? And also URIs, right? And then especially how do you discover your entities or resources? REST gives that hypermedia interfaces where you can say, you make a query, that response will tell you what all the different resources that are hidden there, and then you can traverse them. So the discovery is easy, right? That is why HTTP methods are used for common protocol for your CRUDs, that is the create, read, update, and delete operations. And Redfish interface is exposed as a common web service endpoint, so which makes that developer's life much easier, right? And then I talked about the hypermedia API. The entire URIs, a small set of URIs are defined, which is well known, and once you start interacting with those URIs, you get the information about what all the remaining management entities which are hiding there, right? So that is about the entire protocol. So it's very simple and intuitive, right? I mean, in the web world, as I said, the web scale manageability problem is intuitively solved by a web-based management interface. That's what I said. So a little bit more details into the Redfish model. So it's a hypermedia-based protocol where the Redfish client and Redfish server, they talk HTTPS, and then the mode of data transmission is in JSON. And the Redfish server actually stores that information about the managed entities in the OData format. That's again OASIS standard open data protocol. There are a lot of libraries which knows how to parse, how to convert OData into JSON and then transfer it over this wire, right? So that is a common technological aspect. So protocols are core data models and behavior. So what DMTF did is they took this HTTPS plus REST and JSON combination and said, we define a set of schemas, right? And every vendor can adhere to these schemas, and then the entire management transactions are easy. So it's about the protocol is the REST-based commands, especially the get, put, delete, post, right? Those commands, and how do you ensure that you can do that entire system management using those verbs, the REST HTTP verbs. And Redfish interface, which is RESTful, I mean, which has the standard web semantics. And then common models, the data model is common but extensible, right? And then easy to discover. The entire topology discovery is easy, so that you don't have to worry about heavyweight discovery mechanisms. So that is a whole aspect of the Redfish. And from an advantage perspective, we think it is secure because HTTPS brings a security which is default, scalable, given that it is REST and you can talk to any of the entities independently, and in a scale-out environment, it is much more easily usable. Extensible because the data model can change. So the data model has enough extensibility built in. So if a vendor wants to add more features, manageability features, more actions, we can easily add extensibility, and commonly used language, commonly used protocol and interfaces, like let's talk about the JSON and REST. Now, a little bit detail, because if we want to talk about what we are doing, right? So more detail into the Redfish protocol aspect, right? So any manageability, right? Any manageability interface will need some of this, right? One is OData convention. As I talked about, the entire managed resources are modeled using OData. We'll see how that is in our demo. And it's model oriented. So the entire manageability resources modeled using OData, which has no dependency with the protocol. The protocol and the schema can change because there's no hard dependency between them. That's the primary concept of REST, right? The client and server don't have to agree on anything. The client and server can change independently. So that is the model orientedness. And synchronous and asynchronous operation, because say a volume create, right? And most of the NAS servers we worked, volume create, if the volumes are going probably more than 1,000, 2,000, the volume create takes a lot of time. 10 minutes, 12 minutes, there are NAS servers which takes that much time. Now, say for example, a reset operation, right? How long it takes to come back with a response. So there should be support for time-consuming tasks like async operations. So you make a request, the server is taking its own sweet time to do that, and then comes back with the response, and you should be able to manage that. So that's the asynchronous operation. So the protocol has a support for that. And event support, right? When something catastrophic happens, which are time-critical events or alert or errors has to be sent to the management client. So that is the event support that's also there in this protocol description. And actions, like, I mean, rather than the common CRUD semantic, you want to support custom actions, let's say a firmware update or a reset, right? Because the HTTP get, post, put, or delete doesn't really help these actions. So now, how do you extend these intrinsic actions to support more complex actions? So that is the action support. So these are the main, I would say, 5 protocol aspects that Redfish brings in, and that's what SwordFish is built on, and that's what we are using in our this demo as well. Yes, please. OData is the standard that OASIS comes with. In the schema level, there's not much difference. The difference is it comes with an OData ID, where the layout is almost same, just like XML, but it provides the OData ID, which can give you a handle. So that is the only difference. So it is something that Tosca came up with to manage and identify each of the objects. Otherwise, it's more or less same as JSON. Okay. So now, SwordFish, right? So now, the Redfish was the basic block, right? DMT came out with, and they said, okay, this is an interface that most of the server vendors can adopt to, so that the server management is made easy. Now, they left out most of the storage aspect of it, right? I mean, how do you model a complex storage system? Because when you talk about a server, maybe it has a direct attached storage and at the maximum probably a RAID connected to it, right? Now, they had a support for that. Now, when SNIA looked at it, they said, okay, the entire storage aspect is missing. Now, how do you add the complex storage systems and storage services can be modeled using the same protocol for manageability? So that is what SwordFish is. SwordFish is an extension to Redfish, which allows the complex storage systems and storage services to be modeled and integrated to the manageability aspect. So it's an extension to Redfish to support storage and model for scalable storage and associated data services, right? I mean, as I talked about, any storage system now, people talk about storage services, right? That is the entire software-defined world. You would talk about set of storage services being exposed. So now you should be able to model that. And so the services includes probably snapshot, replication, mapping, masking, right? All that provisioning, all that service level orchestration. And then it supports a wide range of storage. As I said, the question is, does Redfish has the similar capability? Redfish supports probably a direct attached disk or a RAID to the maximum, but this model, the schema supports RAID arrays or file server, converged systems, hyper-converged everything, right? So that support is there. So that is what a SwordFish is. SwordFish is an extension to Redfish schema, which supports the high-end storage servers. Now, SwordFish data model, right? So which we talked about, the protocol is same, right? It is HTTP and your REST interface, and you have the standard verb. So the protocol is not big deal to think about. The deal is in the schema, right? So here I'm just showing an example of the Redfish schema and SwordFish schema. If you talk about every Redfish server, right? I mean, I'm not sure it's very much visible. There is a /redfish/v1, like any HTTP endpoint, any web server endpoint. So you have we call it a service route, right? And the service route is a well-known URI. So once you know the service route, you can query, doing get operation, you can get all the resources and managed entities hiding behind it. And that is represented by the schema. And at the server side, this will be modeled using OData. Right, so this is what we are seeing as a sample representation, but the actual on-disk representation will be OData. And when it comes to the client, it comes in a JSON format because OData to JSON conversion happens. Now, from a Redfish entry point, you can get to collection of systems, collection of services, collection of systems and chassis information. So you can get the entire topology of systems in the Redfish. And SwordFish, what is added is, you can see this /redfish v1 storage services and the storage systems. And the storage system can have a special IDs, right? I mean, you have five different storage systems. You can have /redfish/storage system /1, 2, 3, 4 like that. So you can give an ID and you can traverse through that. And same way for storage services. And each of the storage service can have, if it's a volume or share, if it's a block or a file storage, you can have a volume, share, replicas, that information. This is a sample one, right? The spec talks about almost 180 different schema entities. So this is just a sample representation. Or if it's a storage system, you can have disks, controller, interconnects, all that modeled. So the schema is the core part. Once you understand the schema and how to talk and get information, then the job is done. It's a collection of systems. I think that's a typo there. It's not a collection of storage services. As I said, Redfish model storage services is only disks and RAID arrays, not more than that. Same API, same API. Oh. Who? From the storage system, correct. So once you query, so for example, look at the Redfish/V1 storage services, right? So once you query that, do a get operation on that, you will also get how many storage services are there and how to get them, right? So that next level of links you will get. And using that you do a get again, you will get the next level. So that's how it's, so that's why I talked about the hypermedia interface, right? Just like you go to an index.html and it has more reference to the pages which are hiding. So similar way. So now, I think it gave some amount of picture of what is Redfish, SwordFish, and what manageability aspects provides. And when we thought about it, we were thinking, okay, what do you want to make, sorry.
Sorry to interrupt, I just wanted to ask you about the mock translation. How does it get translated?
So there is a CSDL, right? I mean, common simple data language format. So there is a library which actually converts. So that's what they are using now. So there's a CSDL which actually converts the OData to JSON format. So when we talked about this, I mean, how do you make the developer's life easy, right? I mean, because if I'm a storage management application developer, I'll be a good JavaScript or AngularJS programmer. And should I be worrying about what is the Redfish schema? How do I worry about getting the information, all that stuff, right? So we thought, okay, it makes sense to make a standard JavaScript library, right, which can be imported onto your application. And that library should abstract most of the heavyweight, right, talking to Redfish, SwordFish, and all that stuff. So that's what we thought about. So now, any business goal of storage, any business goal of a SRM, right, so a storage resource manager is, you have some business goals and you want to convert that into a storage actions, right? If you want to have, I want to create extra 2 terabyte of pools, and that needs to convert to create pool in the storage system, right? So that's about a storage resource manager's task. Then like mundane monitoring, diagnostic and all that information. So basically configuration and provisioning, resource monitoring, event and log management, how do you pull events and show the critical events to the users, performance assessment, we'll talk about that a little bit in detail in the demo, diagnostics and fault detection, accounting of resource consumption, right? So those are the kind of typical usage. Now, the deal is the management application should talk SwordFish, right? If you are using this manageability, they should talk SwordFish. So that is what we are trying to reduce, right? So goal of this library is you provide an easy way to access that SwordFish resources from your application, and you abstract the protocol, the protocol complexities behind the scene. That's what this our library is doing. So it's a set of JS APIs that wraps your get, patch, put, post, delete, the common verbs, common HTTP verbs, and they provide a predefined set of JSON objects, because and as an application programmer, I need, okay, get volume, right? Get volume / volume1, right? Now, once I get the volume, I want that in an object format so that I can use it for my rendering or any action that I can do. So that's what we are doing here. So this library will provide you the objects, storage objects, which you can easily use in your management application. And the objects will be built, updated, and made. Soumya will talk about our details of that implementation and one of our demo where we are showing how easily you can develop a management application using the library, right? Over to Soumya.
Structure of our SwordFish JS library, or that's what we're calling it. So the library itself has 2 layers. One is, it is at the lower level. It has it's just a wrapper around the the Redfish calls. So the Redfish has is supporting some HTTP calls to provide the services it does, which is get, delete, put, and post and update operations. So what the Redfish wrapper does is just a wrapper around these calls, where it takes the OData ID, or rather the ID for that particular for a resource that we are looking for, and then it calls it does takes care of calling the request and the response to the Redfish or a SwordFish server. And underlying, we are using an open source library called OData.js, which is the Olingo OData.js, which is a library that takes care of most of the request response operations that we need to make here. So that is the underlying the request response layer we have. And on top of that, we have our library itself, where we have a set of predefined objects, as Vinod talked about. We have this. We have modeled our storage system and storage services with a set of predefined objects. So these are some of the basic objects that are required for an SRM for a SRM application, a management application that is required for monitoring and configuring for monitoring and configuration applications and functionalities. So that is what we have, and then so each of these objects have a set of APIs that are taking care of some of these operations on them. So a client, once it makes an API call, it is a very simple call from the client perspective. It just makes an API call to get what it wants. For example, a storage pool or a storage volume or something like that, and then the call is then made to the Redfish wrapper to actually take care of the request response structure there. And then the call is made to the server, and then we get back the response there. We give the client the response. So this is a structure of the request response structure for our application. So as you can see, we have a JS application, and then that actually talks to our JS library, and then the call goes to the Redfish wrapper, and then to the server, and then back again. So from the client perspective, once again, it's a simple API call that it needs to make, where and then the library itself has all the built-in intelligence to sort of take care of, okay, I mean, this is the call that has come in, this is the data that I need to send back. So what are the Redfish calls that I need to make this happen? So that is something that that intelligence is in the library. So it makes all the the relevant calls to the SwordFish server, and then gets back the data to the client. So that is the normal request response structure, and then we have a event for asynchronous events. So here, when the events are generated from the server, it is so the way that it works is you have to subscribe to that by giving a location or an IP of your application, and then a post call is made to the client or the application itself from the server to give you the events and notifications. So what that also would be taken care of the library, where it gets all these events and then takes care of updating the objects itself. So that's the idea here. So this is what we have so far on our predefined set of objects. Once again, this is something very basic as of now. This will probably change, as in we might add more attributes, remove attributes, add more, actions and things like that. On top of this, as our development progresses and as we find our, more demands and things like that. So, so what we have so far are these. These are, what we think are the basic objects that model the storage systems and the storage services. And so, yeah, we have, storage system, storage pool, and all of this. And I just saw the sign that I have 10 minutes, so I'll be rushing through this. Have any questions, stop me. So, so yeah, what we have today is a fully compliant RedFish wrapper, as I talked about, it's just a wrapper that takes care of most of the complexities of handling the request and response. And then we have the object wrapper for some of these objects, which with some basic CRUD operations on them that would take care of that. So what we are yet to define and implement are the event-based and custom action on objects. Event-based, as I talked about, subscribing to the events and taking care of that, and then performing some custom operations on the objects itself, for example, that don't that don't relate to any of the CRUD operations. So that is something that we are, where we are. So yeah, so like Vinod mentioned, we have a small demo that we want to present. It's a very basic POC application that is, proof of concept that takes our, or rather makes use of our library and just does some monitoring operations on that. So what we have in the demo setup itself, we are using, first of all, we are using the mockups that SwordFish provides. SwordFish basically has this mockup server on their website, which you can use for your purposes. So as this is really not very widely adapted as of now. We don't really have a product to play with. So we decided to go ahead and take that, the mock server, and use that. And that, there are some limitations there, as in, it doesn't provide you all the options to do all the CRUD operations, as in create and update and all that. But for your basic monitoring purposes, it's pretty good. So the other thing is we are using a Grommet application or a sample application that we have found. The reason we are using that is Grommet is a sort of a relatively new framework that has come up, and they have this simplistic, very, I think they call it essential experience. So a simple mobile-first UX design, experience that they go with in this framework. And that is basically what we are also trying to do, is in, simplify the whole management experience. So we use that application and sort of made some changes in there for our purposes for this demo. So what we have in the demo is some monitoring information on the system itself, and and the pools and volumes on that. So we have the dashboard here. So this is basically, this is something that sort of relates very well to what we are doing here, where they are getting all the system information in some basic information about all the components in the system at one go. So very simple. I'm using some get system, get storage pool, get volumes, and it gives me some get logs and some of these very basic operations. Instead of doing a huge number of RedFish calls, I'm just doing some basic operations. And this sort of when we're talking about scalable applications that Vinod was talking about, this sort of pretty much relates well to what we were trying to do with the dashboard, wherein it's supposed to give you overall overview of the system itself. So then we have volumes. Not loading some data here. So yeah, so once again, some enough data about volumes to get you, some basic information about the volumes, and then we have storage pool itself, and once again, then there needs to be some details going in here. What we basically want to add here, and what's something that is pretty important in terms of especially monitoring and management application, is performance and diagnostics, which is something that we want to add here, and that is where we found the challenges with this with the RedFish specification. I'll talk about that next. So yeah, this has been a sort of a learning experience for us as well. We have gone through we've started with this as beginners in this whole technology, RedFish and SwordFish, and we've gone through what it is that we can do, or rather, for our purposes, how it is that we can make this work. And For us, a pretty good learning is obviously, how to map all these objects that I showed you earlier, how to map all of that to the redfish schema itself, how to get all the information that we want from the schema itself. And then the discovery process itself, as Vinod was talking about, you have to, so basically the idea here is that, you start with a service route, and then you traverse through that to get your resource model. I mean, you basically get all the components in a system starting with service route, and that's your discovery. So that is another thing that was a learning experience, as in, most of the intelligence in our library has gone in to make that work. So basically to make sure that we traverse through all the components and we get what we need, because we are basically abstracting this complexity to the end user, right? So they don't need to know this, but we need to basically handle all of this. So this is something that is a learning experience. And then handling async operations, once again, the way that our library works is, a simple request response. So to make that work for providing an event-based request response kind of a structure. So how to do that? That's another learning experience. So the next three items are not, or basically there's some limitations that we found in redfish, the schema itself, the SwordFish redfish schema. Well, maybe it's the limitations, or maybe it's the way that we are interpreting the schema is, maybe that's where it needs to happen. But either way, we found the limitation, as in, when we were trying to, a simple thing, I mean, it's when we were trying to figure out we get snapshots along with volumes when you do a get volume on a redfish schema itself. So the snapshot is basically a volume object. So how do you differentiate between a volume and a snapshot? So unless you just had to look at the source volume parameter of a particular object to see if that is okay. If that is populated, then yeah, I mean, this is a snapshot because it has a source volume, which is, I mean, at least that's the way that we found. We couldn't find anything else. So that's probably not a good way to differentiate a snapshot. So that's one thing that we wanted to put there. And the other thing is performance and diagnostic. And like I mentioned earlier, we want to actually make sure that we give all the performance and diagnostic capabilities for a management application to the users. And that is where we found some limitations in the schema, where we couldn't actually make that happen, as in we couldn't find, or we couldn't equate what it is that we want with the schema itself to come up with what, come to basically implement this. So that is, those are some of the learnings and shortcomings that we found.
The SwordFish JS library, what you are doing it on the client side, those can be incorporated in the server side itself. So what is the exact benefit of this on the client side, doing it in the client?
So yeah, I mean, where do you want to do most of the operation, right?
Usually, yeah, any redfish server what we develop, right? Any vendor or any, so they do all the incorporation of all these things in the server side itself. So what exactly we will be benefiting with the SwordFish client side JS library?
So this is something that you can equate to SMIS, right? So how is it that SMIS worked? It was basically a standard where suppose customers has a bunch of storage components from different vendors. It's a standard, and they used that to make sure that they are managing multiple, different kinds of different vendor components, and making their application work. So this is basically something like that. I mean, this obviously will not work if somebody is providing all this application on the server side itself. Obviously, that's a different
but compile that only we have a schemas, right? So all the vendors, whoever is developing the redfish or SwordFish, they have a schemas. They need to follow those DMTF specifications and then develop it. So with that, yeah, why you need this JS?
The need for the client side is right. I mean, you want to do certain operation on the client side. I think, yeah, we are out of time. Got it, Paul. So yeah, we just want to ensure that if a application has to render this information, right, he needs that information here, right, and then all the processing has to happen on the client side. So server side implementation will be there to provide you the, say, get response or put response, right? But when it comes as a JSON format here, the application has to do some work on it, right, so on the client side. That is what we are trying to avoid. So we can talk about more in detail. Maybe there is a... Okay, thank you. Thanks a lot.